Hello, welcome to a short lecture on reading text files using Scala.io.source. The ability to use files is fairly essential for a lot of programs because once a program terminates, it loses everything, so you need to be able to write data out to files so that you can load it in again later. It's also nice to be able to read files in just so that you can get a lot of different data into your programs, things that you don't necessarily want to type into the source code itself. So we'll start off using the REPL to look at how we can do this. Now, as was mentioned, the type we're going to use is Scala.io.source. Now that's a fairly long name. What this says is that there is a type called source which is located in a package Scala.io. And because I don't want to have to type in that long name all the time, I am actually going to use an import statement which tells Scala that if it can't find something, it should go look in a particular location. And I am going to import Scala.io.source. The advantage of that is that from that point on, I can just refer to it as source. You can also put import statements in your scripts so that you can use shorter names for things. Now, when I want to get the source for a file, when I want to read in some data from a file, I can do something like, I'm going to call the from file method. So let's go ahead and let's make ourselves a source. Now note that if I hadn't done the import, I would have had to type in Scala.io.source there. And I give it the name of a file. We'll start with a little file that I happen to have sitting in this directory called matrix.txt. Now you can see what this gives us back is actually something called a buffered source, which is also inside of Scala.io. Buffered source just does a little bit of extra processing because reading from disks is a slow thing to do, so that it speeds things up so that everything is read in big chunks. The more interesting aspect of this is over where it says non-empty iterator. An iterator is much like a list or an array. It is you can think of it as a sequence with one major difference. It is a sequence that is consumed when you use it. So we can call the methods that we're used to using on list and array. For example, I can take source and call mkstring on it, which will read everything in, and I wind up getting a string. This is the contents of the file. However, unlike a list or an array, if I now look at the source, you see there is a change. Now I have an empty iterator. As I read things in the first time, they were consumed and they are no longer there for me to read. And that winds up being significant to us in what we are going to do here. So, in order to get this back, I'm going to open the file again. Iterators themselves are really based upon two methods, one called hasNext and the other called next. So while the source still has stuff in it, I can call hasNext and it tells me true because there is stuff there to read. I can call next to get the next value. And we see that we get a single character of 0. If we call it again, we get a character of point, and if we call it again, we get a character of 5. And you can see those are indeed the first 3 characters here. Turns out that the source itself is an iterator of care. And so every time that the values in it are single characters. Technically, you can use that to do whatever you want, but most of the time it is helpful to have whole lines. For example, I don't want single characters here. I would like to have, actually I'd really like to have these individual numbers, but if I get the whole line, I know how to split it apart and get the numbers off of it. So there is a method on the source. Let's go ahead and let's refresh our source. There's a method on source called getLines. So let's put that in a variable called lines. And when we call that, once again, we have a non-empty iterator here, but this time it's an iterator of string. And so when I call lines.next, I get the entire first line. I call it again, I get another line. Just to demonstrate, there is still something else there, but if I pull it off and then I check has next, it's false, and lines is empty. Okay, so here you can see that we can use the source to read out the contents of a file. You can use next and has next, but because it is like a sequence and we can use all the other methods that we're used to using on sequences, there are often easier ways for us to interact with it. So to really demonstrate this, we want to write some scripts. So first, let's go ahead and do simple reading.scala. I'm going to put my import statement up here so that I can use the short name, source. And I want to, there are two different things I want to do. It turns out I have not only the matrix file in here, I also have a file for a box score from a San Antonio Spurs basketball game. And so I want to show how we can read in each of those and get them into a format that might be reasonably useful to us. So we'll start with the matrix. Now, well, I'm going to call this matrix source because I'm actually going to have two sources in this file. Equals source.fromFile, and the name of this file is matrix.txt. So I put that in there. I am going to get the lines from that. And so now I have an iterator of strings that will iterate over all of the individual components. But what I'd really like to have, in the case of a matrix, is an array of double. Okay, that's a nice way to represent a two-dimensional matrix. In case you were wondering where these numbers came from, they're actually an affine transformation, which is something that we will learn about in a few chapters when we talk about graphics. I want to take each line, split it apart. Let's go back and let's look here. So the lines are, in this case, separated by comma space, or at least the numbers on each line. So what I want to do is I want to take each line, I want to split it up on the spaces, I want to take each of the values and convert them to doubles, and then convert that whole thing to an array, because otherwise I will get back an iterator. And I can do this very nicely with the use of map. And this is why having the source, which is a Scala collection, winds up being fundamentally helpful in that we can use the same types of techniques that we're used to. So when I map over all the lines, I'm getting an individual line. And what I want to do is I want to convert it to a string, or from a single string to an array of strings using split. And then I want to convert each element in that from a string to a double. Call toArray at the end to get everything out. Now, one of the things that we didn't do in the RAPL, but when you are programming, when you open a file, every time you open a file, you need to make sure you close it. And the reason for this is that you're only allowed to have a certain number of files open at any given time. Now, you can't close the file before you're done using it. In this case, this line right here, I'm still using matrix lines, and it is the iterator. Had I closed before this line, we'd wind up having problems with that. We can put in a line. Let's do matrix dot for each print line row print line RMK string with just a space in between the values. And if we come over here and we run that Scala script, it prints out the matrix. And so this matrix is sitting in the memory, and we could do whatever it is that we wanted to do with a matrix. The other file that we have in here, this box score, has multiple lines, one line for each player. And to keep things simple starting off, we'll just read it in and just get an array of strings. So let's do, how about we call it the score source dot from file of box score dot txt. Do not leave off our double quotes so that I don't forget it. I'm actually going to go ahead and put in the call to close. I'll have to make sure that everything that uses it comes before that line, but that's better than forgetting to close it off. So score lines equals score source dot get lines. And what I can do here, I'll say that box score is equal to score lines dot map line goes to line dot split on, and over here it is worth going into VI to note that, notice that that's a single keystroke, so is that. These are separated, unfortunately that one. Okay, yeah, all of these are separated by tabs, okay, not by spaces. And that winds up being significant because as we are, well, we'll see. Because when we split, if I want to split on a tab, I can do that. If there were spaces, we could put in a little bit more logic to deal with that. We're going to assume right now that it's all tabs, and we can come back and look at what that gives us. And how about we also convert this to an array so that we have the box score. At that point, it's safe to close it. Print line, or let's run through the box score. Box score dot for each of player print line. Just so that we can make sure we see this, player.mk string. I'll put in some nice spacing to make sure that this is highly visible. And when we run this, you can see that we're clearly getting things separated, and in fact definitely all of those were tabs because they're spread out. Now, of course, what might be nice to do would be to do things like, let's say I wanted to print only the line for Manu Ginobili. Well, in that case, I could do a print line of box score dot filter, and I want the line such that the first element contains Ginobili. Okay, now that's going to be an array, so, or when I filter the array, I get back an array of arrays. So I will pull off the 0th element and then do a make string with spaces in between it. Now let's check, make sure that we have that all nice and happy, and you'll notice that Ginobili printed out here at the bottom. What if I want to know the total number of points scored in this game? Well, the last value winds up being points. We could count 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. It's sub 14. We could also get that by finding the length, so val calls equals box score sub 0 dot length. So then calls minus 1 would be the last one. And if I want to know the total points in this, val total points equals, I want to run through the box score, and I want to pull out just the last element, calls minus 1, and then I want to sum those up. Let's see, we have, oh, that is correct. Well, it looks like a 14, well, it is a 14, but it's the string 14, and I can't call sum on that. So in order to get around that, what we are going to do is map the strings to int. And now if we run, we see that in this game, Spurs scored a total of 116 points. So that is a brief introduction to using the source to read in values from files, and we'll have another video that does a more extensive example and plays around with a larger data set.